Question number 6 from the MSP practice test is a exponents problem. And to solve this problem, you need to understand a little bit about exponents. And so I'm going to rewrite this problem down here so we can see what it really means, so I can write it out. So we have 5 to the 6th power, all of that squared, and then to the negative 4th power. Now some of you may be tempted to just put those numbers in your calculator and get an answer, but the question is not asking you to do that. It's asking you to rewrite this in exponential form. And so we want to simplify it. In other words, we want to get rid of parentheses, we want to make this as simple as possible and then leave it in exponential form. So you have to understand what this means. First of all, 5 to the 6th power, if you understand that, means 5 times 5 times 5 times 5 times 5 times 5. So that's 5 to the 6th power. Now if you square something, that means you multiply it by itself. So what we're asking now to do is to take all of this and multiply it times itself. So all of these, all 6 of these, multiplied again by 6 more sets of 5. 1, 2, 3, 4, 5. 5 times 5 times 5 times 5 times 5 times 5. 5 to the 1st power, 2nd, 3rd, 4th, 5th, 6th power. Which means we're going to have 5 times 5 times 5 times 5 times 5 times, do I have enough there? 5. There we go. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So now I have 5 to the 6th power squared times itself. And so if you think about that, that's really 5 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12th power. That's 5 to the 12th power. That's what I have so far. But then when I multiply it times 5 to the negative 4th power, now it's interesting that negative powers, when you have something to a negative power, that's like if I said 5 to the negative 1st power, that's the same as saying 1 over 5. So negative powers are actually create fractions. So what I'm going to do with that 5 to the negative 4th power is I'm actually going to rewrite it on the bottom of the fraction, because that's what the negative tells me. It's actually not a negative number, it's a negative exponent. And when you have a negative exponent, it just means that that's on the bottom of the fractional part. And I can do a proof there later on at some point to show you how those actually come about. But for right now, I'm just going to show you how to get the answer to this problem. So 5 to the negative 4th power, these are going to go down below because that's really 5 times 5 times 5 times 5. And so now what I have, if you look at this, I have all of these 5s on top and I have a bunch of 5s on the bottom. And if you think about it, if I take a 5 divided by a 5, that's a 1. 5 over 5. So if I think 5 over 5 equals 1. And I have 1, 2, 3, 4 sets of 5 over 5. So 4 ones, really. And it's 1 times 1 times 1 times 1. Then what I'm left with, this is all that's left. Once I simplify, I have 5 to the 1, 2, 3, 4, 5, 6, 7, 8th power. So I'm left with is 5 to the 8th power when I simplify this and then leave it in exponential form. And again, there's all of these different pieces or parts to look at. All of these 5 to the 6th power twice squared, and then 5 to the negative 4th power, which again creates a division part of this. Now, I could have, if I understood these, I could have realized that 5 to the 6th power is 5 to the 12th power, 5 to the 6th power squared, because I had 12 of those, over 5 to the 4th power, because that's what 5 to the negative 4th power is, means 1 over 5 to the 4th power. And if you just take these exponents and now subtract them, 12 minus 4, I get 5 to the 8th power. Because really that's what I'm doing. I'm canceling out sets of 5. There's 1, 2, 3, 4 sets of 5 that I'm going to cancel out that are basically divided out, become 1s, and I'm left with 5 to the 8th power. And that's how you simplify and then leave an exponential form. Something as complicated as this becomes as simple as 5 to the 8th power.